What is Linux? Well, many of you would have used Linux or heard about it in your day to day work, and many of you say, yeah, it's an operating system just like Windows or Mac OS. A couple of you who have some understanding on Linux history or its lineage, you would say it's a free open source alternative to your everyday operating system like Windows or Mac OS. So, in this video, we will learn about the aspect of what exactly is Linux and how it originated with a little bit of history on Linux. So to begin with, I should tell you that Linux is a free Unix clone operating system kernel project. So I will break that down. First of all, when I say free, many of you might think it's free as in cost. You can get Linux freely without having to pay any money to anyone. Well, that is true to a large extent because Linux is freely available. You can download Linux and install on your computer without having to pay any license to anyone. That's a known fact. But the free here is got to do with freedom, which means that Linux is not just free as in cost, but free as in freedom. What is this freedom here? Well, you can download Linux source code, review the source code, understand how the operating system works, make some modifications or customizations to your liking, and you can also distribute modified versions of Linux to others. And you can also charge money for it. Nothing stops you from charging a price for the modifications you made from the Linux kernel that you derived. That's the kind of freedom that the Linux ecosystem thrives on. So it's a free Unix clone. When I say Unix clone, it's got a lot of inspiration from Unix operating system. So you'll see a lot of similarities of Unix and Linux to a point where Linux sort of adheres to common Unix standards like the POSIX standard, which I will talk about in a while. So it is a completely Unix compatible operating system. But then would I call it a Unix operating system? Not really, which I will show you in the next slide, that Linux is treated differently than other Unix variants, right? And it is a kernel project. When I say it's a kernel project, an operating system is generally a full stack suite of programs available. So if you have used Windows on your computer, maybe a Windows or Mac OS, the everyday operating systems on your general purpose computers like laptops and desktops, you would note that you don't just get the kernel alone, you get a lot of tools. So when you install Windows, you get access to various tools and utilities as a user. You have a desktop interface on which you could use a calculator or a notepad, or you use a web browser to connect to the internet, and various other applications are bundled with their entire stack of operating system. Whereas Linux, on the other hand, is not a full stack operating system. Generally, it's a kernel project, and people who have used Linux as end user, like if you're using a Linux desktop on your machine, you should note that these desktops are generally called as Linux distributions. I'm sure you heard about Ubuntu or Red Hat Linux or Rocky Linux or Debian or Arch Linux. There are so many distributions available. These distributions are the full stack operating systems built on top of Linux kernel. So Linux is technically one major component, a core component of an OS, which we call as a kernel. So it is technically just a kernel project. And it is written from scratch by Linus Torvalds. What I mean to say is that most Unix variants descended down or branched out from the original Unix operating system built at AT&T Bell Laboratories. Whereas Linux, on the other hand, is written from scratch. They did not derive any code from any existing Unix. It started off like as a very small Hello World like project, slowly adding features from various community members, right, across the internet. And Linus Torvald has been working as a release manager for this project. So it is a built from scratch operating system kernel. And it has been volunteered by several thousand developers, hackers across the globe who contribute and maintain code for various subsystems and maintain them, and also drivers for various hardware devices on Linux kernel. If you look at the official definition for what is Linux, you will find that on the Linux kernel source tree, like you see here, this is a README document from the Linux kernel source code, right? If you download the Linux kernel source code and walk through the trees, you'll find a file called README. These days, it is in the documentation/admin guide folder. In this definition on what is Linux, it says Linux is a clone of operating system Unix, written from scratch by Linus Torvalds with assistance from a loosely knit team of hackers across the net. What I should tell you here is that Linux is one of the earliest products of the internet evolution. I guess you know that the World Wide Web evolved in the late 80s. Sometime during 1987, 88, 89 time frame is when the World Wide Web originated. Those days we had the World www websites. Even today we use them. But you also find things like FTP servers, and we had Gopher and all other kind of protocols in the early days, and Usenet groups and so on. Linux is a product of that internet community. So in the earliest version of Linux, the first version of Linux that Linus Torvalds created, he published it on an FTP server at a university where he was graduating, which is Helsinki University of Finland. So when he put the source code of this kernel that he wrote, a very simple bare-bone kernel that he wrote on the internet back in August 1990, thousands of people across the internet downloaded them. Many of the people who are operating system hobbyists and enthusiasts, they saw an opportunity to add features to this kernel project that Linus Torvalds created, adding various features, various subsystems slowly, and over a period of time, with several thousand contributions coming from people across the globe on the internet. A lot of these features were inculcated into the kernel to become a full-blown operating system that we see today, right? So that's why they say it's a product of the internet. It aims towards POSIX and single Unix specification compliance. These are the two major standards that govern Unix compliance, which I'll talk about in the further slides. It has all the features that you would expect on a modern Unix operating system. If you look at Unixes like Solaris or HPUX or IBM AIX or SGI IRIX, all of these are true Unix derivatives or Unix variants working on different hardware that was manufactured by those companies. Linux tries to be a free alternative to these commercial Unixes. It aimed towards having all the features that commercial Unixes had, like support for preemptive multitasking, support for virtual memory and demand paging, support for full stack, multi-stack networking, and support for copy and write support on CPUs that support them, and support for various features that you will see on normal Unix-based systems. In fact, today Linux fully replaces most of the commercial Unix variants, even on those exotic hardware that the vendors produce, right? So that's what Linux has become. So look at the Linux comparison with other Unixes. Well, if you look at the Unix landscape, the Unix operating system originated at AT&T Bell Laboratories, but then the initial versions of Unix were available in source code format for people who requested them, mostly companies and universities back in the days. I'm talking about in the 70s timeframe. And there were many branches of that AT&T Unix that originated over time. Like we had HPUX, DEC Unix, Ultrix, and later on we had SCO Unix and many other Unixes. They all branched out, all based on the code base of AT&T's Unix operating system. There was also one of the earliest fork of AT&T Unix that was BSD Unix, and it had its own forks again, own branches. Like the BSD Unix became FreeBSD in the later years, in the late 80s and early 90s. From FreeBSD, there were like fork like NetBSD. From NetBSD, there was a branch out from Open to OpenBSD. Then in the later years, there was something called Dragonfly BSD. So this is a BSD family. They fall into a separate group of Unix variant operating system. And then we have recently taking cues from Linux, the Solaris operating system. They tried to recreate it from scratch. This was initially funded by Sun Microsystems, and I think Sun was acquired by Oracle. Eventually, the project called Open Solaris got forked off as an open source project, completely open project called Open Indiana Project. It is still an ongoing project where a lot of interesting innovations are going on. That is specifically for Solaris ecosystem. We have OmniOS, Open Indiana, Illumos, and all of these projects which are forked off from Open Solaris. And we also have Haiku operating system. That is a Unix-like operating system which is free. And just like Linux. Again, it is also in a way written from scratch, taking inspirations from another commercial operating system called BEOS, which was popular, slightly popular in the late 90s. It had some popular, probably it was quite popular amongst the how across the enthusiast community, but it didn't really make it big. But HaikuOS is like a spin-off open source alternative for it. So all of these are other variants of Unix that exist. Linux tries to separate itself by two important things. One, they won't call it Unix because they're not part of the Unix consortium that is there today called the Open Group. Unix is a trademark and a copyright currently held by a consortium called the Open Group. Linux community is not part of it. That's why they will never use the word Unix to describe their OS. They say it's Unix-like. They say it's a clone of Unix, but they say it's not a Unix operating system because they don't go through that certification process from the Open Group. That's one thing. And it is also written from scratch, which means that Linux kernel was not derived from any existing code base. So Linus Torvald wrote it from scratch with contributions from thousands of community members across the internet. And that's why Linux is treated separately from the other Unixes that I've shown you in this place, right? So that's what you should know. So as I already mentioned that Linux is merely a kernel project. It is not a full stack operating system, which also means that the Linux kernel developers, including Linus Torvalds, do not really care about what desktop must be used on Linux. They don't make a call on what desktop to use, what libraries to use, what kinds of tools to use, what kind of init subsystem to use, and all that. Which means that Linux is more malleable in a way that you can customize Linux suiting to your specific requirements, right? It's not very rigid in its structure, which is very unlike other operating systems, other mainstream operating systems. Consider, for example, Windows. When you install Windows, you don't have a choice to decide how you want to have your desktop look and feel to a great extent, because what Microsoft ships, you have to use it. If you have to customize a desktop and say, I want to use my own custom desktop environment, which is having a completely different theme and completely different look and feel, it's very difficult to do that, right? The same happens with even Apple macOS. Very difficult to customize macOS completely for a different use case. Imagine taking a macOS operating system and putting it on different embedded hardware with different libraries and different desktop. It's not easy, right? It's not easy. The same goes with even the open source competitor for Linux, which is FreeBSD currently. FreeBSD is the toughest competitor for Linux in the market today. From the earliest days, if you ask me who is Linux competing against, it would always be FreeBSD. These are like two flagship open source Unix based operating systems or Unix like operating systems, which in a way were like edging each other in terms of features. FreeBSD is more rigid, which also means that it's difficult to take a FreeBSD kernel and put your own custom library and all that. It's difficult to do it. It's a full stack operating system. Whereas Linux is merely a kernel project, and the full stack OSs that we use built on Linux, or we call them as Linux distributions and desktops and servers. If you know that Android, which we use on your smartphones, right? Smartphones and Android TV and so on, this is built on top of Linux. They use the Linux kernel, but have a completely different stack on top of it. A fully customized application library stack on top of it, suitable for a particular hardware and particular target audience, right? So that's what Linux ecosystem is all about. You should note that Linux is fully compatible with Unix. That has been one of the primary aim of the Linux project. This actually gave an advantage where a lot of the programs and applications and libraries need not have to be fully rewritten for Linux. All the existing libraries, existing programs and software which were built on traditional Unixes could be easily ported on Linux, as Linux is fully compatible with Unix. So this is how Linux thrived and garnered a lot of attention from the Unix community back in the 90s, right? And it's trying to maintain compatibility by using POSIX standards, which is Portable Operating Systems Interface for Unix-like systems. This is an IEEE standard. It's found by the IEEE consortium, where they try to create a standard based on various Unixes that existed in the 80s, and they try to form out a standard which is like a subset features and functionality that every Unix should have. So if you want to create a operating system that's compatible with Unix, if you follow the POSIX standards, is very much compatible with various other Unixes. And Linux followed that standard. That's what makes it more Unix compatible. Linux implementation was developed completely from scratch, already told you, unlike many other Unix derivatives, which were based on 88 Unix. And the Linux development process is fully decentralized. This is one thing that actually makes Linux really stand out, because there's no one single governing body that governs and says this is how things must happen on Linux. So you'll have a lot of variations of Linux suitable for different kinds of use cases. You have Linux for desktops, Linux for servers, Linux running on data center kind of applications for cloud and so on, Linux running on various embedded devices, Linux running on appliances like smartphones and TVs today, and various other devices which have a screen where user interface is required. So this gives a complete flexibility and creating your own way of doing things without adhering to any specific governance or any kind of standard that's been put forth. So the entire development has been decentralized, making Linux all pervasive today on various other devices other than the PC, of course. If you look at the market share of Linux, I think it's got a major market share in every other kind of computing environments, be it server market or embedded systems or specialized supercomputers. That's where Linux is pretty much a dominant player in those areas. The only place that Linux is not very dominant is on the desktop and laptops and your personal computers generally, simply because the hardware that is created is tailored for Microsoft's operating system. Or if you're using an Apple MacBook, I guess you know that is developed by Apple for running their operating system. So apart from these areas, I think Linux has been a dominant player in various other computing environments, right? And if you look at the very high level architecture of the Linux system, you will have the hardware at the low layer. Then you have the kernel. The kernel sort of provides an abstraction to the hardware. So your hardware configuration and hardware architecture can change without majorly changing anything on the application tier. So think of Linux as an abstraction layer on top of the hardware. Plus, it also takes care of managing various resources, which I will talk about in the further videos. So on top of the Linux kernel, we have the library layer. In the library layer, we have different kinds of libraries, different choice of libraries. Your standard desktops and servers might be using the GNU-C library, also called as glibc, but there are other alternatives available like the microcontroller C library, also written as uclibc, found with BusyBox deployed environments, mostly on embedded devices like routers and modems and so on, and various other appliances too. We also have something called MUSL, which is another alternative to the microcontroller C library and glibc, which is released with MIT license. The licensing is a little different, which is more liberal in a sense, which is Muzzle C library, also called as Muzzle C library or MUSL. So we have different kinds of libraries. We have choice of libraries. On top of libraries, we have the programs which are compiled and built or linked with these libraries to communicate to the kernel, to make use of the kernel's features, right? And these applications could be your init system and system management services. So when you boot your Linux system, you will see that the kernel is booted, and after the kernel boots, there's bootloader and firmware initialization, all that I'm just skipping. The kernel boots. The ultimate role of the kernel is to initialize the userland by running a user space init program. The init program falls into a category called system management services because it is the init process that actually manages everything that happens in the user space, that is the application tier. So all the programs that you're running, like your desktop environment or all the different tools and services running, all of these are managed by init in some way. It takes care of logging, hot plug, and many other things, right? We have system management services. And again, these also come from various projects. So if you're using your standard Linuxes these days on desktops and servers, very likely you will find systemd being used as the project for system management. But you do have alternatives, like you have the BusyBox init. If you're using embedded systems and boards, you might also have other variants of init, like we have OpenRC and we have supervisord and so many other different variations of system management services. Apart from that, we have the compilers, language runtime, build systems, and tools. which provide the development environment for developers to write programs. And this could be writing a C program, C++ program, Objective C program, and so on. We have myriads of languages supported on Linux, Rust, Golang, you name it. So every popular programming language is supported on Linux by the compiler and language runtimes. With the language runtimes, you could actually have programs written in a very high level language like Python or Java or even C Sharp. So we have high level language programs running on top of language runtimes. And then we also have various command line tools for systems management, be it managing files and directories, or managing processes, or managing hardware features, or various other aspects of your system. These are available on a terminal or on a command line. This is also called as command line tools, and they work on a shell. So there's a default shell interface on a command line. I'm sure a couple of you would have worked on terminals, would have heard about Bash or Z shell or Fish. There are different shells available, and Linux supports different kinds of shells, and though Bash is most commonly used. And when you have the shell and command line tools, we can also do a lot of automation using shell scripts. Some of you might also write scripts in Python or Perl or TCL. Different other languages are also supported to write scripts for automation. And we also have a graphical user interface. Today, when you use Linux as a desktop, like I'm doing right now, I'm running a desktop that's running on Ubuntu. This desktop interface that you see, it comes from a different project. Currently, I'm using GNOME desktop. It's pronounced as GNOME or Genome. It's GNOME, right? GNOME desktop. We also have KDE, we have XFCE, we have like hundreds of different desktop environment variants, right? Depending on different users and their choices and their tastes, we have different desktop environments suiting their requirements. And these desktop environments would be running on a graphical user interface stack, which is predominantly by the Xorg project. Earlier it was called as X386, but now it's called Xorg project. And this Xorg project takes care of your graphics layer. You had X Windows System Server. Right now, there's a migration or transition on major desktops to Wayland. It's been happening for a decade or so. And various tools and applications that we all use as everyday users or as even developers are available on the graphical user interface stack. Be it your web browsers or your development environment like Visual Studio Code, or if you're using the GUI version of Emacs or Vim editors, all of these tools are available in the GUI stack. So all of these fall under applications. What you should note is that most of these tools come from their own independent projects. There's a separate set of projects and groups and communities for systems management on Linux. There's separate project groups for libraries, separate project groups for compilers and language runtimes and their tool chains, separate projects for the shell, be it Bash or KSH or Z shell or Fish. So many shells available. And we have separate projects like KDE project and GNOME project, and we have XFCE project, LXDE project, and so on. So we have all of these are like independent communities in their own regard. So the development is fully decentralized, but there are somebody called distribution vendors who package them together, bundle them to create a full stack operating systems that we all can use for our use case requirements, right? So this is how you look at the very high level architectural layers of a Linux system. So you should note that when you talk about Linux kernel project, it is only this particular block that you see here, the one in the yellow block. That's what the Linux kernel developers are mostly focused on, right? They only develop features that go into the kernel. They don't care about what happens in the library layer, or what happens in the compiler tool chains, or what happens in the system management. That's not their business, right? So that's how things are here. So we'll look into the brief history of Linux in the next video. So I'll talk about how Linux originated and the complete history on how Linux came out from Unix in the next video. Thank you.